Hey everybody, back to full adder digital circuit again. So previously I did talk about design full adder circuit using LTSPICE, but for this one it's going to use the LTSPICE 4 that you can free download from our internet. And we're going to use the same circuit, and just to compare how to do our simulation and the final output for the sum and carry out. It's very similar to the PSPICE, I mean for LTSPICE. It just be some different, so that's why it's going to be a good opportunity to take a look at their LTSPICE. So when you open LTSPICE 4, you simply go to File, you go to New Schematic, and then we're going to start drawing the circuit. So let's minimize the PSPICE window, and I take this one up so you can see better, and you'll be able to compare two of them. Okay, sorry, let's take a little bit down. Okay, look better. So let's pick up somewhere to pick up to exclusive OR gate. You simply go to I have to pick up time here to see the ways. Okay, better. So you go to the component icon, you go to digital, you click OK. You can see what exclusive OR. So you click OK, you did two of them. So you left click to place, you left click to place again, and you right click to stop. You go to AND gate, which is here. You left click to place, right click to stop. The last one is the OR gate. Click OK. You place somewhere between here. That's going to be your carry out output. And for more understanding, you can see that LTSPICE gives you 5 inputs exclusive OR gate, and the same as the 5 input AND gate, right? It also gives you the output, inverted output and non-inverted output. You see, this one is, you have the circle right here. That means you have inverted the output. If your output is 0, if you pick up this one, your output is going to be 1. So you say that LTSPICE put everything in one component. You can either choose the 2 input are exclusive OR gate, or 3 or 4 or 5. Okay, I just leave some pins disconnected if not used. And again, for you can take a look at this one here. For in the real circuit, if you pick up some IC, right, you cannot just leave some pin floating. You need to connect the rest of your pins to either ground or 5-volt supply, depend on what is the gate. For the AND gate, you need to connect the pin that's not used to positive 5-volt supply. But for OR gate, you need to connect the rest of your pin that's not used to what, to the ground, right? Because for the OR gate, if you want output follow your input, whenever you have a logic 1, your output is going to be 1, right, for OR gate. So you cannot leave unused pin connected to supply voltage 5 volt or the logic 1. You need to connect that pins to ground, and it's work on opposite route for AND gate. You need to connect unused pins to the positive 5 volt or logic 1 if you want your output follow your input, because whenever your input is 0, that means your output is going to be 0. Okay, so this is just something that I want to add up, to the logic gates, because I can see from LTSPICE it's come with 5 inputs. Okay, so let's get back to the circuit then. Let's move this guy to the top. So this one I move. Just draw the rectangle, around components. You right click to stop, and then you minimize to be ready to draw the circuit. Now for your logic input, in this case you have CIN, right, and A and B. For LTSPICE, you don't have a digital clock as the PSPICE, this guy. So you need a DC supply. You go to component, you go back to the system library, and then you pick up voltage. You click OK. In this case, you need a 3 input logic. So you use the 3 voltage sources, and also you need grounded. Now start to wiring then. Connect this one to ground, this one to ground. Okay, and this guy, just leave it there. And then for your circuit here, you connect your non-invert output to exclusive or A2. This is going to be slow, just because you have to be careful. Then let's do the connection again. For A1, you did 1 pin connect to the input A, right? So let's change this one to be A, just to make it clear, and this guy to be B. You simply right click on V. Oops, sorry. You tell this one is B. Click OK. And this one you click right click, and you put CIN. That's the C input. CIN input. Now pin number 2 of A1. Where does this go? Let's go to the input B, right? So you simply make the connection here. So you already finished 2 input connections, 2 pins. And then your output of A1 or exclusive or also connect to A3. And then you can see this one, pin number 2 of the second exclusive OR connected to NAND AND gate. Oops. You can choose one of these. Okay. And then you also get the input from our CAN, right? You can see from this here. So let's do the connection. That's why I say it's going to be a little bit slow. And you need to be careful that you not connect to this guy. And now this one, you're going to take a non-inverted output of A2 to be sum. So just draw a wire of it to be able to label this one as your sum, right? So just place this on the line, the box. Now for the second AND gate, both connected to the input A and B. So let's finish this up. See, so this one, you take input from A, you go to the second AND gate, and also the input of B, you go to the second pin of your AND gate, or A4. And now you do the rest. You take the output from both AND gate to the input of your OR gate. So that's pretty straightforward. Okay, let's take a non-inverted output. Alright, almost done. Take a non-inverted of your A5 and you label it as the carry out. Oops, not the routed space. So let's put underscore here and put on the warrior. Okay, that's going to be your carry out. Now the next step is very crucial step, is that you need to set up your input that corresponds to the truth table. So your input simply, as we worked this one out before, you have off for 4 seconds, right? And on for 4 seconds. And you have period of 8 seconds. So for C-in, you right click on your device, you go to advanced. So we're going to use we're going to use pause. The initial is mean you start from 0 for the signal, and for the on it's 1, right? The delay, this one's supposed to be pause, and actually it's pause, but LTSPICE not allow you for T delay is mean like you switch, just apply, so you don't need delay, you simply put that in 0. For T rise is mean your signal is supposed to be start from 0 to 1, or you can draw the line perpendicular to the vertical horizontal axis, or X, right? But LTSPICE not allow you to put 0 in here, so you can put a very small number of your time. So I simply put 1 nanosecond, or 10 to -9, right? do the same thing for the fourth time. That's 1 nanosecond. And T on, you want this one to be 4 seconds, right? Corresponds to the truth table. We have 1, 2, 3, 4. And also T period. You want that one to be what, 8, right? You can just leave your end cycle right there. Now you can click on OK. Next you move to the input A. You go to advanced, you go to pause, you do the same thing. Initial to be 0, and then V on to be 1. The delay, you don't need that, so put 0. And T rise, 1 nanosecond. T4 also 1 nanosecond. T on, this corresponds to the truth table here. It's like you have 2 seconds, right? And your period is double of that, so it's 4. Click OK. The last one, you go to V3 or input B. Go to pause, you go initial, you go on to be 1, delay to be 0, T rise 1 nanosecond, T4 1 nanosecond, T on 1 second. So your period is to be double, so that's 2 seconds. You click OK. Now you're done. You're ready to do our simulation. Okay, let's bring this up. So this one is difficult. Oops, sorry. Just move some of them so you can see better because it's overlapped. Go to this guy and move this down here. Okay, so that's better. Next step, you need to go to edit. You need to go to Disperse Analysis and you look for transient for the stop time. As you can see, you want to see the whole logic combinations. In this case is what, 16, right? Is it 16? Yeah, to the Q. Actually it's just 8, right? So only your 8 does cover all logic combinations. Let's push this stop time to be 10 then. You click OK. You place this is transient. The final time is 10 seconds. That's what the meaning is. And then you go to simulate. You go to run. It's going to give you a plot. So let's start with you go to the icon here. Pick visible trace. Let's start with okay, I don't have CAN here. I don't have input A and B. So you need to go back to the circuit and do the level net. Oops. Where is this? Oh, disappear. Oh, it's just right here. Okay. So let's put this one as their CAN. And let's right click this guy to be A. This guy to be B, right? Oops. Let's see. It's going to show up your output. So you do simulation. Maximize your plot. Go to trace. Still doesn't show. Okay. Let's get back to the circuit again. I have a problem with this guy. So it's back to zoom out. So if it doesn't work, let's label it. on the line. So put CAN right here. Okay, let's mark the line as the reference. So the event is here, it's the A. Make sure you put the, yellow or the box. Okay, hold on a second, sorry about that. Okay, sorry about it, let's continue. So the last one you need to label is the B input. You go to label net, and then you type B, click OK. You place your input B right here, and you do simulation again. You go to the plot, maximize, and then you add plot. So okay, it's already show up here. So you have VCAN, you start from there. This is your VCAN. There's something like funny here because they're actually, I don't understand. Okay, let's continue. Take a look at the VA. Okay, this is correct, right? Because never on for 2 seconds and off to be 2 seconds, or logic 1 for 2 seconds and logic 0 to be 2 seconds. You go to plot setting. Oops, don't want to add plot plane. Delete plot plane. Okay. You go to plot. You go to add trace. You go to B. Okay. Alright. Okay, the problem here is that you have some problem when you add trace into the same plot. It's difficult to see. So let's kill this guy. Oops. Let's delete this guy then. Cut. And then go to add plot plane. That's your VA. Now you add another input, which is B. Click OK. So it's better to compare, right? You need to add plot plane for what? Input. Oops, sorry, let's start over again. I should take like CAN, A and B, right? So let's kill these guys. So that's not gonna take long. Oops. Address. Start with CAN. Okay. Oops. Alright, let's start from this one and sorry about it. CAN, click OK. You go to add plot plane. Something wrong with CAN, but we'll come back to correct that later on. VA, plot setting, add plot plane. You go to address for VB. Okay, so you have A, that's correct, B is correct, but C somehow is something weird. You go back to your circuit, LTSPICE. Blow this up. Totally gone. Oops. It's not responding. Sorry guys. Have some error. Let's stop this one a little bit. So come back to talk about that later. Okay, let's get back to this one again. So you have okay, your simulation command. Sorry about that because I have some error with the previous program, so I have to redo or set up again, reset again. Stop time is going to be what, like 10. Click OK. Alright, so let's take a look at the plot. Let's add threads. start with third. Sorry, I have to go back to our circuit again. So you need to go to the circuit here. Eliminate. Sorry about that. This one going to be, let's put it as the CAN first. Let's go to check the circuit again. So your CAN is probably going to that's A and B. A and B. Oh, sorry, I have to redraw the circuit. Sorry guys. Okay guys, let's get back to your circuit again. So I'm going to do run, and then let's see your input CAN. Oops, something wrong. Oh, sorry, I need to go to setup again. So that's what, 18, right? Go to error. So CAN. Go to advanced. Go to post. This one's 0. V on is 1. T delay is put 0. T rise 1 nanosecond. T4 1 nanosecond. T on, that's going to be like 4 seconds. T period is 8. So click OK. And then you go to also input A. Go to post. Initial 0. You have amplitude is 1. T delay is 0. T rise 1 nanosecond. T4 1 nanosecond. T on, that's going to be like 2 seconds. Period is going to be double T on, so that's 4. Okay. The last one is B. Go to advanced. You do the same thing. Pause. Initial is 0. T on 1. T delay 0. T rise very small number 1 nanosecond. T4 very small number 1 nanosecond. T on is only 1 second. T period is going to be a double of T on, so it will take like 2 seconds. Okay, let's make it to see better. Move this guy down here. Move this guy up here. Okay. So you know the pause, like this is your on time 4 seconds and your period is 8 seconds. For input A, your on time is 2 seconds and your period is to be double, so it's 4 seconds. Make sure you got it right. For input B, T on is 1 second, so the period is double, is 2 seconds. Alright, let's do our simulation again. Go to see the plot. So this is your CAN. And to see it clearly, you go to add plot plane. And next one is going to be input A. Click OK. You see that? So the period is going to be half of this there CAN. You go to another plot plane. You add VB. That's also become half the period of VA. Now you want to see the output sum. You go to add plot plane, and you go to resum. You go to another plot plane. You go to trace. That's going to be oops, sorry. That's supposed to be where's my carry out? Okay, let's go to see the circuit. This is my carry out. Doesn't matter. Liberate that again. Liberate it. Carry out. Alright. just put on the line, and then do simulation again. This is your full header, so you add first you carry out right here. So finally you can compare to your truth table. Okay, if you do it great, you should have no problem to get your output. In this case there are sum and carry out. Okay, so for this video I show you how to use the LTSPICE 4 to do a full adder digital circuit, and then you can compare which one you prefer between your LTSPICE and your Disperse. For myself, this one seems to be like real time. That can easily to work with. Okay, I'll see you in the next video. Okay, bye.